physical properties of aldehydes and ketones. Important. What are the physical properties of aldehydes and ketones? So in the previous chapter, we discussed about the physical properties of alcohols also, right? So here we are moving to the physical and chemical properties of aldehydes and ketones. Okay, so as we discussed in case of alcohols, there will be also in case of aldehydes and ketones, there are different property, how they are, what is the solubility, what is the nature of the compound, they have, whether they have high melting point or low melting point, like that. So there is a particular reason behind all these properties. We are going to discussing about that properties. See, first one is physical properties. Methanol is in gaseous state. See, all these physical properties you have to memorize. I am telling you again, memorize the properties. Methanol is in a gaseous state and ethanol is in volatile liquid state. Methanol is in a, it means it is a gaseous compound. Ethanol is a liquid compound. And other aldehydes or ketones are liquid or solids at the room temperature. Okay, the first point. Next one, the weak in molecular association in aldehydes. It is weak. Intermolecular interaction. What is intermolecular interaction? We know, right? So the weak molecular association in aldehydes and ketones due to dipole-dipole interaction. I told you, there are three types of intermolecular interaction between the molecules. We have three types of interaction. First one is dipole-dipole interaction. Second one is van der Waals force. Van der Waals force. And the third one is hydrogen bonding. These are the three types of intermolecular forces. So in case of aldehydes and ketones, the one of the important type of intermolecular interaction is dipole-dipole interaction. Okay, see, the weak molecular association in aldehydes and ketones due to dipole-dipole interaction makes the boiling points of the aldehydes and ketones higher than that of the comparable molecular mass. Okay, the absence of intermolecular hydrogen bonding, in acids and ketones makes their boiling point lower than that of the alcohol. In the last topic I told you, the alcohols, between the alcohol molecule there will be hydrogen bonding. Why? Because the alcohol contains oxygen, so that oxygen is electronegative, they can make bond with the neighboring molecule using the hydrogen atom between the alcohol. Due to the absence of this type of hydrogen bonding here, in case of ketones, they have comparatively low boiling point. So I told you boiling and melting means we are breaking the bonds between the molecules. If the bond is so strong, not easy to break. Otherwise, it is easy to break. Due to the absence of this hydrogen bonding, it is easy to convert them into vapor form. Means boiling point is low. Okay. Due to the hydrogen bonding with the water, the low, see, due to the hydrogen bonding, it is not between the molecule, this is with the water. The lower members of the aldehydes and ketones such as methanol, ethanol, they are miscible with the water. What is miscibility? Miscible means they are mixing together. If you are taking water and oil, they are immiscible, right? Why? If you mix them together, they will, after some time, they will separate into two layers. They are called immiscible. Miscible means they will mix. They won't separate into two layers. They will be a single layer. So due to this hydrogen bond formation, these lower members, when we are moving to higher members like butanol, pentanol or butanone, pentanone, they won't be miscible. Okay, but in the lower members like methanol, ethanol, methanol means only one carbon, ethanol means two carbon, and propanone means three carbon, right? They are miscible with the water. They will mix with the water. See, one example you see, this is a ketone. So any R group, suppose it is CH3, it will be propanone. This is CH3 and this is CH3, it will be propanone, right? So this propanone is, here see, when you are adding this propanone into water molecule, this oxygen is making interaction. They are making hydrogen bond with the hydrogen atom of this water molecule. See, The interaction between hydrogen and high electronegative atom is called a hydrogen bonding. So this water molecule can make hydrogen bond with the oxygen atom of the corresponding ketone. That's why they are miscible with the water. Understood? Yes. Any doubts? If you have any doubts, you can ask me in question and answer session. Okay, you can ask the questions. You can type the questions. I will answer for the questions. Okay, then see, the increase in the length of the alkyl chain decreases the solubility of the aldehydes and ketones. In the previous slides, I told you the lower members are only soluble. They are only miscible with the water. See, the lower members means when the number of carbon atom is increasing, the chain length of the aldehydes or ketones will increases. When the increase in length of the alkyl chain is there will be a decrease in the solubility. When the chain length is increasing, the solubility will decrease. So what are the factors affecting the solubility or miscibility? First one, they are making hydrogen bond. That's why the lower members are miscible or they are soluble in water. But in case of the higher members, they will be insoluble. They will be immiscible because the chain length with the number of carbon atom is increasing. Aldehydes and ketones are soluble in organic solvents like benzene, methanol, chloroform, ether. See, I told you. I will tell you one formula, simple formula. Formula means it is not a chemical equation. It is a simple sentence. See, like dissolves like. Like dissolves like. This is the equation. It's not a chemical equation. Okay, this is a simple sentence. So this simple sentence we can memorize all these points. Like dissolves like. What is like dissolves like? Means similar compounds will dissolve in other similar compounds easily. Suppose hexane can dissolve in propane or propane can dissolve in hexane because they are normal hydrocarbon. At the same time, if you are taking one alcohol and normal alkane, they won't be miscible that much. Why? One is alcohol, other one is hydrocarbon. So like dissolves like means similar compounds. If they have similar polarity, they have similar functional group, they will be miscible. So this is the equation. Equation means not a chemical equation. I am telling you. Understood? Not a mathematical equation. No. It is the sentence. Means the word used to memorize this solubility. Like dissolves like. Okay. The lower molecules of aldehydes have a sharp pungent odor that becomes more fragrant in any increase in molecular mass. Okay, the lower molecules of aldehyde have a sharp pungent odor that becomes more fragrant with an increase in molecular mass. When the number of carbon atom increases, it will increase. Okay, but the chemical properties are important. Chemical properties means they are mainly the chemical reactions. How the aldehydes or ketones are reacting with some other compounds, or what are the name reactions, what are the different reactions in which the aldehydes or ketones are participating. Okay, so that is the chemical reactions are called, that is called a chemical properties. Chemical properties means the chemical reactions itself. Okay, so we are moving to the chemical properties or chemical reactions. See, first reaction of these aldehydes and ketones is nucleophilic addition reaction. We know what is a nucleophile, right? What is a nucleophile? Nucleophile, as I told you, they have a negative charge. They have a negative charge and they like nucleus because the nucleus have a positive charge. So the nucleophile means that compound, the species will have a negative charge or they will have excess electron, means they should have lone pairs of electron. Then only we can call it as a nucleophile. Okay, so in contrast, electrophilic addition reaction in alkenes, nucleophilic addition reaction occurs in aldehydes and ketones. So the important type of reaction occurs in the aldehydes and ketones are nucleophilic addition reactions. Okay, so what is the nature of this reaction? Suppose, see, in this reaction, in the first step, we are taking a carbonyl compound. Carbonyl compounds with maybe aldehyde or ketone. See, here you can see A and B. A and B means if both A and B are some alkyl group, it will be ketone. If A is hydrogen and B is some alkyl group, it will be aldehyde. Right? Yes. So this is the compound we are taking. Then here see, I am taking C double bond O. Some compound is here, means some group is here, some other group is here. I told you the CO bond is polar in nature. Means oxygen have high electronegativity. So oxygen will get a partial negative charge. Carbon will get a partial positive charge. So what will happen? When a nucleophile is attaching to when the nucleophile is approaching to the carbonyl compound, means aldehyde or ketone, what will happen? See, whatever the group here, leave it. I am talking about the CO bond only. If it is aldehyde, I told you, groups are different, ketones, the groups are different. So whatever the group it may be, leave it. See, the nucleophile is coming. So I told you nucleophile have a negative charge or they have a lone pair of electron. So normally they will go to carbon, not to oxygen. Why? They are nucleophile. They like nucleus. They like positive charge. So this nucleophile moves to carbon, not to oxygen. Understood? Then what will happen? When the nucleophile is approaching the carbon atom, normally already the carbon have 4 bonds. 1, 2, 3, 4 bonds are there. When the nucleophile is attacking the carbon atom, it becomes 5 bonds, right? Because nucleophile is coming to make bond with carbon. So it becomes 5 bonds. Then what will happen? One of the double bond with this oxygen will moves to the oxygen atom. Means here, one of the bond means they have 2 electrons, 1 pair of electron. Both the electrons will move to oxygen atom. Got it? Both the electrons in this double bond will move to oxygen atom. So what will happen? After this attack of the nucleophile, it will be these 2 bonds are not changing. Now you see a new group is attacking there. That is the nucleophile. Then this is a single bond now. This is oxygen. And this double bond is moving to this oxygen, means this oxygen will get a negative charge. See, here they are mentioning the correct position of these 2 groups. See what this dashed line indicates? It means it is below the plane. And this solid line indicates it is above the plane. It indicates it is above the plane. It is below the plane. Okay, so here this group, the A group is below the plane and the B group is above the plane. So what will happen? When this new group is coming, it is not changing, but it is a little bit, it is moving here. See, the A group was here, the group B was here. Then when the nucleophile is coming, these 2 groups are a little bit moving here. That's all. Got it? This is the first step. Then what is the second step? Second step means, see, the product is not yet formed, right? So what is the product? Nucleophilic addition means what you have to get. See, this here still a negative charge is there on oxygen atom. So what will happen? This negative charge containing oxygen atom will take H plus ion from the reaction medium. This is the second step. This is the first step and this is the second step. This is negative charge. This one is positive. So these 2 charges will attract together. Then you will get nucleophile here, 2 bonds. Then oxygen is there and this hydrogen will attack with this oxygen to produce OH. So this is the addition product. Addition product. This one. Whatever the group it may be, leave it. So this is the first step, second step. See, in every 2-step reaction, we discussed about SN1, SN2 reactions, right? So in a 2-step reaction, the first step will be always the slowest step. That is the rate determining slowest step. So here the first step is the slow step, the first one. Means the attacking of the nucleophile and the jumping of the electron. That is the first step is the slow step. Okay, so this is the nucleophilic addition reaction. Then the mechanism, the same thing. See, the nucleophile is the electrophilic carbon atom of the polar carbonyl group. I told you before, right? Then carbon hybridization transform sp2 to sp3. Why it is transforming from sp2 to sp3? See, as I told you, here the carbon was sp2 because this is double bonded carbon, right? It was sp2. When the nucleophile is attacking this carbon, all the bond around carbon is single bond now. Now this carbon is converted to sp3 carbon. In the product you can see it is sp3 carbon because these all the bonds are single bonds. Okay, then by absorbing a proton from the reaction medium, intermediate heats the electrically. See, I told you, I explained all the mechanisms. Okay, no need to explain again, right? Yes. As a result, nucleophile and H plus added over the carbon, oxygen, double bond. That's why you are getting that OH group. Okay, then I explain using one example. Okay, then see, next one is reactivity. If we are moving to the reactivity, see, due to the steric and electrical factors, aldehydes are more reactive than ketones in nucleophilic addition process. See, suppose if you are taking an aldehyde, see, very, very important. See, if you are taking an aldehyde, I told you whatever the group it may be, you can leave because we discussed only the mechanism. Now we are moving to the reactivity. If you are taking a ketone, it will be some R group. Okay, so when the nucleophile is coming here, when nucleophile is attacking here, normally I told you this bond will move to the oxygen and the carbon will get a positive charge, oxygen will get a negative charge, right? Then if the two groups are some alkyl group, bulk groups, what will happen? These, when the nucleophile is attacking this carbon, these two groups will repel the nucleophile. That is called a steric factor. Steric hindrance or steric factor, because if two bulky groups are there, the next incoming group will be repelled because there is no space. It is already crowded around carbon atom. So the next, when the next group is coming, that the groups already present in the carbon atom will repel the incoming group. That's why the ketones are less reactive. Then what is happening in case of aldehyde? In aldehyde, only one is alkyl group, other is hydrogen. Understood? Hydrogen means it is a small atom. Alkyl group is maybe it may be a bigger one, like a propyl group or butyl group, whatever it may be. But the other atom is hydrogen. Means comparing to ketone, in aldehydes there will be a small repulsion because here two groups are there to repel. That's why the carbon is crowded. But here the carbon is not that much crowded because one is hydrogen. So when a nucleophile is coming, no problem, they can easily attack the carbon atom because only one group is there to repel that nucleophile. That's why aldehydes are more reactive in this addition process than that of the ketones. Okay. Then the presence of two relatively big substances in ketone limit the approach of a nucleophile. I told you that one, right? Yes. Then carbonyl group more than the presence of only one such substance in aldehyde. The same thing I explained. Okay. Yes. Next one, addition of hydrogen cyanide, HCN. How the addition of hydrogen cyanide is happening? See, cyanohydrins are formed when aldehydes or ketones combines with the hydrogen cyanide. See, all these very important things. Listen carefully. All these chemical reactions of aldehydes and ketones are due to the polar nature of that CO bond. In aldehyde and ketone, in both you can see the CO bond is polar, right? Because oxygen is more electronegative. Due to this polar nature of the CO bond, all these reactions are happening in aldehydes and ketones, all the chemical reactions. Same thing is here. See, suppose I am taking a carbonyl compound, but if it is aldehyde or ketone, leave it. I am taking a carbonyl compound. I am writing only two dashes. It may be aldehyde or ketone. Then what is happening? Same thing. This double bond is moving to oxygen because of the electronegativity. So they will produce CO minus and this will be positive and the two groups are already there. Got it? Then see, when you are taking a hydrogen cyanide, you are doing these reactions in a particular medium, right? Then see, with the pure HCN, the reaction takes a long time. So a base catalyzes the reaction. So we need to conduct the reactions in a medium. I told you, the medium is a basic medium. You can use sodium hydroxide medium. Sodium hydroxide will produce Na plus and OH minus ions. See, these OH minus ions from the basic medium, because these reactions are carrying out in a basic medium. This base will catalyzes the reaction. So the hydrogen cyanide will react with the OH minus present in the base and produces Cn minus ions. Why? Because OH minus will take the H plus ion, because HCN will produce us. HCN will produce H plus and Cn minus ions. So this H plus ions will be taken by OH minus ion and produces water. So the remaining thing is Cn minus ion only. Understood? Then what will happen? This Cn minus will attack the carbonyl compound. But I told you Cn minus is a negative charge. It is a nucleophile, right? Then what will happen? Cn minus will move to where it will move? A carbon or oxygen? It will move to carbon. Why? Carbon is positive. Cn minus is negative. So the positive negative attraction will be there. So the Cn minus will move towards the carbon atom. Okay. See, already the bond is polarized. I told you carbon is positive, oxygen is negative. So the Cn minus can easily attack the carbon atom. So what is the product you are getting? See, I will write here. Okay. Carbon and the two groups are already there. And this oxygen have a negative charge and the Cn is connected. Cn group is connected. This is an intermediate for this reaction. See, this one. Tetrahedral intermediate. Why it is tetrahedra? Because carbon is connected to 4 groups. So they will arrange in tetrahedral manner. What is tetrahedra? One will be at the middle, one at the top, and 3 will be here, here, and here. Means in the down you can see 3 groups, one will be at the top. That is called a tetrahedral arrangement. So this is a tetrahedral intermediate. Why it is intermediate? Because this one have a negative charge. This is not a stable compound. Intermediates are always unstable. Intermediates are unstable. That's why they are calling intermediate. They are not a there is not a stable adduct formation. It is not a stable adduct, stable compound. It is a intermediate. They are unstable. This is a tetrahedral intermediate because they are arranging in tetrahedral geometry. Got it? Then what will happen? This intermediate, this unstable tetrahedral intermediate will takes H plus ion from the medium. Why? Because the oxygen have a negative charge, right? So what will happen? They have to attack some ions, H plus ion, to get a stable form. So they will take the H plus ion from the medium and this O minus will convert into OH group. So it will be carbon, 2 groups, OH, Cn. This compound is called a cyanohydrin. Means cyano group is there and hydroxyl group is there. That's why they are called a cyanohydrin. Cyano means Cn group, hydrin means OH group. Hydroxyl group is there. That's why cyanohydrin. Got it? Yes. This is the addition of hydrogen cyanide. First I told you, you have to do this reaction in a basic medium. Okay, then what is the use of this compound? What is the use of this cyanohydrin? See, they are valuable intermediates in synthetic chemistry. Synthetic chemistry, you know what is synthetic chemistry? Synthesis. We are producing different organic products. They may be a pharmaceutical product, medicinal product, maybe some other food products. Understood? So these products, these cyanohydrin can be used as starting material. They can be used as reagent for different products. So they have wide usage in synthetic chemistry. Okay, that is the addition of hydrogen cyanide. Next one is addition of sodium hydrogen sulfide. What is sodium hydrogen sulfide? Sodium hydrogen sulfide is NaHSO4. This is sodium hydrogen sulfide, not sulfate, sulfide. SO3. Okay, so the addition products are formed when sodium hydrogen sulfide react with aldehydes and ketones. Same thing. Addition product means everything is same. See, the mechanisms are again same. But the adding group is, instead of the Cn minus, here the adding group is different. That is only the difference. See, the sodium hydrogen sulfide, that is NaHSO3, will split into. How they will split? They will produce Na plus ions and HSO3 minus ion. This is called a bisulfite ion or hydrogen sulfite ion. We can call it as bisulfite or hydrogen sulfite, not sulfate. I told you sulfite. Okay, so the same thing. See, whatever we discussed in the previous one, the same thing. Listen, I am taking the compound. So what will happen? Same thing. See, NaHSO4 HSO3 produces HSO3 minus ion. I told you. See, due to this negative charge, they will attract the carbon. Why? Carbon have a positive charge. Due to electronegativity, oxygen will take the electron. So the product, the intermediate forming here is HSO3 minus and O minus is not here. This is O minus. Okay, so this is the intermediate forming here. This one. Got it? Then the same thing, the same product will form. Got it? Due to steric consideration, the equilibrium position is considerably to the right for the most aldehydes and to the left for most ketones. Same thing we explained. Okay, treatment with the diluted mineral acid or alkali can return the water soluble hydrogen sulfate addition product to its original carbonyl carbonyl compound. See here OSO2H is there, ONA is there, then they will convert into corresponding product. Okay, so this is the addition of sodium hydrogen sulfite. Next one, addition of alcohols. How they are adding alcohols? See, in presence of dry hydrogen chloride means water content is not there. Aldehydes combines with one equivalent of monohydric alcohol. What is monohydric alcohol? We discussed in the last chapter. What is monohydric alcohol? They contains one OH group. To produce alkoxy alcohol, intermediates known as hemiacetals. Important. Again. Hemiacetal. What is hemiacetal? See, this is the aldehyde, right? This one is reacting with a monohydric alcohol, means the alcohol containing only one OH group in presence of hydrogen chloride gas. This one. Okay. See, what is the product you are getting? Same thing. RCH is there. Here, the oxygen is there. The OH group is there. The same thing is happening. Got it? Because this is ROH group will split into the same thing we explained in the previous mechanism. So you will get an intermediate that is called a hemiacetal. Hemiacetal. Okay. This hemiacetal will, then they will take the H plus ion and convert into acetal. What is acetal? Acetal contains 2 OR. See, hemiacetal contains only one alkoxy group. OR means alkoxy group. Got it? Here only one alkoxy group, that is hemiacetal. Here 2 alkoxy group, that is acetal. Okay. Then if you are taking a ketone reacting with a dihydric alcohol. Dihydric means here you can see 2 OH group. Then what is happening? See, here you are getting a cyclic adduct, right? See, these CH2 groups are there. They are connected. So you will get a cyclic adduct, this one. And the other product is water. Understood? Same thing. The same mechanism is repeating here. But the thing is here, instead of that Cn minus and HSO2 minus, everything is different. Here it is the OR group, alkoxy group is connected to the carbon. All other things are same. The group is different. Okay, so this is called only one alkoxy group is hemiacetal, 2 alkoxy groups are there, that is acetal. Understood? So this is the addition of alcohols. Okay. Next one, addition of ammonia and its derivatives. Addition of ammonia and its derivatives. How can we do the addition of ammonia and what is derivatives of ammonia? Ammonia means it is NH3. What is derivatives of ammonia? Ammonia means nitrogen is connected to 3 hydrogen. One of the hydrogen is replaced by some other groups. Means the group is represented as Z. That is called a derivatives of ammonia. Okay, the Z may be any alkyl group or aryl group, any group it may be, leave it. So whatever the group it may be, the corresponding compound you will get, that's all. So the same thing is happening. This is the carbonyl group. So this is the ammonia derivative. So this will be NH2Z. Got it? Then what will happen? See, the CO group, the oxygen is negative, carbon is positive. Then the OH group is there, means one hydrogen will move there, and the remaining, see, this is NH2. From that, one hydrogen will go to oxygen. It will be like this. See, I will draw here. Okay. C double bond O. So this bond is moving like this. This will be positive. This will be negative. So what will get? What you will get? C. These bonds are there, and this one, this oxygen is there, and this NH2 set, right? They will split into H plus and NHZ minus. This NH2 set will split into H plus and NHZ minus, means one hydrogen will remove as H plus and the other NHZ minus group is still there. Then automatically this NHZ will move to carbon atom. Why? This is negative. So they will attract to the positively charged carbon. So you will get NHZ here. And this oxygen, right? So this oxygen is connected. This one have a negative charge. So this hydrogen will come there. It will form OH. This one. Okay. Then what will happen? If you want to produce the correct product, means this is an intermediate only. If you have to produce the final product, you have to add some H plus ions. Then what will happen? That H plus ions will take this OH group. Then automatically this carbon will get 3 bonds. 1, 2, 3, because this OH group is moving with this bond itself. Then the carbon will form double bond with this nitrogen. See. Otherwise, you can say this hydrogen is moved with OH as water. That is very simple. That will be simple. Okay. So this carbon is making 3 bond with normally with the nitrogen and the other 2 groups. Then they will, if the OH group is removed, they will make 1 more bond. That will be the final product. Okay. That's all. Then I told you the set may be any group, alkyl group, aryl group, any of the group. Okay, this is the mechanism. See, in every reactions, the mechanisms are same. Oxygen is negative, carbon is positive. So whatever the incoming group, the group will split into 2. The positive will move to oxygen and the negative will move to carbon. The same thing. But you have to know how that one is splitting. Okay. Next one is reduction. Okay. First is reduction to alcohol. How the aldehydes and ketones are reducing to alcohols. I told you, in order to take place the reduction reaction, we need a reducing agent. We need a reducing agent. The reducing agent we are normally using, I told you, what is that? Lithium, aluminium hydride or sodium boron hydride, NaBH4 or LiAlH4. So what will be the product? Aldehydes and ketones. See, the opposite. I told you, primary alcohols on oxidation produces aldehydes, secondary produces ketones. The same is happening here. Aldehydes on reduction produces primary alcohol, ketones on reduction produces secondary alcohol. Same thing, opposite. Because oxidation and reduction both are opposite, right? So same thing is here. Primary alcohol producing aldehydes. So aldehydes on reduction produces primary alcohol. Secondary alcohols are producing ketones. So ketones on reduction produces secondary alcohol. The thing is, instead of oxidizing agent, we have to use some reducing agent. That is the difference. Okay, this is called a catalytic hydrogenation. Why? Reduction means it is the addition of hydrogen or removal of oxygen. So here we are doing the addition of hydrogen. So addition of hydrogen means one more name you can use. That is what? Hydrogenation. So you can say either reduction or you can use the term hydrogenation. Both are same. Got it? Yes. Next one, hydrocarbon reduction. By using the reduction, by doing reduction on hydrocarbon, you can produce the same product. How? See, treatment with the zinc amalgam, and see, the reagents are important. Zinc amalgam and concentrated hydrochloric acid. They will ask this question, sure, because this question is repeating in past papers. Got it? Zinc amalgam and hydrochloric acid. That reaction is called a Clemmensen reduction or Clemmensen's reduction. That's why I told you this is important, because this is a name reaction. Okay, so in Clemmensen's reduction, what we are doing? We are treating the compound with the zinc amalgam and HCl, hydrochloric acid. Or you can take hydrazine. Okay, followed by heating with the sodium or potassium hydroxide in high boiling solvents such as ethyl alcohol or ethynyl alcohol. That is called a Wolff-Kishner reduction. Reduces the carbonyl compound of aldehydes and ketones to CH2 group. See what is happening here. This is the compound, right? Ketone. Reaction with the zinc amalgam and HCl. See, this CO group is converted into CH2. Next one. If you are using hydrazine, see, both the reactions are same. But what is the difference? Here they using the reagent we are using is zinc amalgam and HCl. Here we are using hydrazine. Hydrazine means NH2. That is hydrazine. NH2, hydrazine. Okay, so if you are using zinc amalgam and HCl, that is Clemmensen's reduction. If you are using hydrazine, that is called a Wolff-Kishner reduction. See, the products are same. The CO group is converting into CH2 group. That is reduction. Reduction means addition of hydrogen and removal of oxygen. From this carbonyl compound, we are removing this oxygen and we are adding the hydrogen. In both the reaction, that is same. But the reagents are different. Okay. Yes. Oxygen is removing and hydrogen is adding. Got it? Next one is oxidation. See, in their oxidation process, aldehydes differ from ketones. See, in every these reactions, I told you aldehydes and ketones are behaving similarly. Means whatever the reaction happening in aldehyde, the similar reaction is happening in ketones also. But the thing is, the groups are changing. In ketone, it will be 2 alkyl group. In aldehydes, 1 is alkyl group, 1 is hydrogen. That is the difference. Oxidation processes, it is different. Okay. When exposed to common oxidizing agent like nitric acid, potassium permanganate, potassium dichromate, aldehydes are rapidly converted to carboxylic acid. Important. If you are using a normal oxidizing agent, what are the normal oxidizing agent we are using? I told you, whenever they are asking about the oxidizing agent, the first thing come to your mind is should be potassium permanganate and potassium dichromate, KMnO4 and K2Cr2O7. Understood? So, when you are using a normal condition, when you are using a normal oxidizing agent like potassium permanganate, the aldehydes will convert into carboxylic acid. Aldehydes will convert into carboxylic acid. Okay. Even moderate oxidizing agent like Tollens reagent and Fehling's reagent oxidize aldehyde. Normal oxidizing agent, I told you, this is KMnO4 and K2Cr2O7. And also nitric acid we can use. But some other oxidizing agents are there. They are called a Tollens reagent and Fehling's reagent. I will tell you what is Tollens reagent and Fehling's reagent. Okay. Before that, this one you will do in your practical. So no need to worry about that. You will see the change with the aldehydes. What is the change with the Tollens reagent in aldehyde? What is it with the ketone? All these changes you will see in practicals. Okay. See, when you are taking an aldehyde, they will oxidize into acid. Now, ketones are typically oxidized under vigorous circumstances, that is with the powerful oxidizing agent at a high temperature. Understood the difference? Normally, aldehydes will undergo oxidation in normal conditions with a mild oxidation. Mild means normal oxidizing agent. But in case of ketones, we need a powerful oxidizing agent. We need a strong oxidizing agent. Not only that, we have to heat the solution. Then only the reaction will happen. Means that the oxidation of ketones need high temperature condition. That's why in practicals we are heating the solution. Got it? Their oxidation involves the breaking of carbon-carbon bond, resulting in variety of carboxylic acid with fewer carbon atoms than with the parent ketone. See, this is the ketone I am taking. So I told you, aldehydes with a normal condition, they will produce acid. If you are taking a ketone at a stronger oxidizing conditions, understood the difference, right? Here, mild condition, here stronger condition. Here acid we are getting. Then what is the product here? See, here you are using strong condition, but the product, what is the product? Before the product I told you, the carbon-carbon bond is breaking. Then after the breaking of the bond at C1, C2 means this is the first carbon, this is the second carbon. This bond is breaking. And one group is converting into acid group, other is also converting into another acid group. So you will get R, this CH2 is converting into COOH. And this R dash CH2 CO group is converting into R dash CH2 COOH. See, this is converting into this one and this is converting into this one. Okay. Next, one more option is there. What is the next option? Next option is you can do this bond breaking here also after this CO bond, because see, around CO bond the groups are different, because this is R, this is R dash. What is the difference between R and R dash? There may be different groups, right? One may be methyl group, one may be propyl group, other one may be ethyl group, or this one may be butyl group, any group it may be. So the opposite products are also possible. This one will produce one acid and this one. Got it? So these two bond may break, or bond breaking may be here also. Got it? That is the oxidation. Now, tolerance and fillings test. As I told you, this is important because we have to differentiate the aldehydes and ketones using tolerance and fillings test. What is the reason? I told you, normally aldehydes and ketones are participating reactions in similar way. I told you the products may be similar, only the groups are different. They both will give the similar products, only the substance will be different. But the tolerance and filling test we used to differentiate between aldehydes and ketones. Okay. So what is tolerance reagent? What is fillings reagent? Or what is the difference between the reaction of this tolerance reagent with the aldehydes and ketones? Will all the aldehydes will react with the tolerance? If all the ketones are reacting, if all the aromatic and aliphatic are reacting in similar way, that all we have to know. Okay, so we have to know what is tolerance test. See, come to the point. A bright silver mirror is produced when a freshly prepared ammoniacal silver nitrate solution, that is called the tolerance reagent. Ammoniacal silver nitrate solution, AgNO3 solution. Ammoniacal means silver nitrate we are mixing with the ammonia. Silver nitrate we are mixing with the ammonia. That is called a tolerance reagent. Okay. So this tolerance reagent, we see in two test tubes, in one test tube I am taking aldehyde, in other one I am taking ketone. Okay, so what will happen? I am adding this tolerance reagent to both the test tubes. First one is containing aldehyde, second one is containing ketone. Any aldehyde or any ketone, whatever it may be, leave it. Normal aliphatic aldehyde and ketone I am taking. So what will happen? Then I told you we have to heat the solution because at high temperature only ketones will react. I told you. So for what you have to do? Heat both the solution. If the aldehyde is reacting with the tolerance reagent at normal condition, they will react with high condition also, no problem. So heat the solutions. Then what will happen? See, a bright silver mirror is produced when a freshly prepared ammoniacal silver nitrate is heated with the aldehyde, because silver metal is formed. See, this aldehyde will reduces this silver nitrate solution, ammoniacal silver nitrate solution. See, this is the tolerance. See, now silver nitrate reacted with ammonia. This is the reagent forming after this reaction. So when this aldehyde is reacting with the tolerance reagent, see, in the product you can see silver. Silver metal means they will precipitate. See, this is also called a silver mirror test. It is not here, so point it out. Silver mirror test. This test is also called a silver mirror test. Why this is called a silver mirror test, you know? Because the precipitate forming is silver. It will be looking like a mirror. Understood? It is not a black precipitate, actually it will be silver color. So it will be looking like a mirror. That's why they are called a silver mirror test. So aldehyde will respond to this test, tolerance test or silver mirror test. Means they will produce silver precipitate when react with the tolerance reagent. Got it? Then ketones, they won't give you the product. Got it? Next reaction, Felling's test. Tolerance test is clear, right? Just add the tolerance reagent to the aldehydes and ketones and heat it. Aldehyde will give you the silver mirror precipitate. Means the silver precipitate. That's why they are seeing as a mirror. A precipitate means silver color precipitate, silver metal precipitate. Next one is Felling's test. Felling test means Felling solution we have to add. Instead of tolerance reagent, we have to add the Felling solution. But the thing is, Felling solution is not a single solution. They contains two types of solution. Felling solution A and Felling solution B. Then what is Felling A and Felling B? Felling A is aqueous copper sulfate solution. And Felling B is alkaline sodium potassium tartrate. Okay. So we have to mix the copper sulfate, means Felling solution A and Felling solution B. We have to take equal amount. Take equal amount of copper sulfate solution and sodium potassium tartrate solution and mix together. That is called a Felling solution. Felling A plus Felling B. Okay. Then what you have to do? See, I told you, you have to take in equal amount. Then same thing. Add to this Felling reagent is added to the aldehydes and ketones. I am one test tube aldehyde, other test tube ketone. I am adding the Felling's reagent to the both the test tubes. I am heating it. Then a reddish brown precipitate will be produced when Felling's reagent is heated with the aldehydes. In tolerance reagent, aldehydes are giving what? A bright silver mirror. Means you are getting a silver precipitate, a silver colored precipitate, metal precipitate. But Felling solution is giving a reddish brown precipitate with the aldehydes. Ketones, they won't give you the precipitate. So we can differentiate aldehydes and ketones using tolerance and Felling's test. That's why these two tests have importance in analytical chemistry, practical chemistry. Got it? Yes. So tolerance test is a bright silver mirror. Felling's test, you are getting reddish brown precipitate. Understood? Next one, oxidation of methyl ketones by haloform reaction. What is haloform? Chloroform, you know. Iodoform, you know. They are commonly called a haloforms. Sodium hypothalite oxidized aldehydes and ketones that have at least one methyl group attached to the carbon atom to sodium salts of the corresponding carboxylic acid. Sodium hypohalite. What is sodium hypohalite? NaOX means sodium hypo, any halogen, it may be hypochlorite, anyone. So commonly we can represent with the X, NaOX. React with a ketone, they will produce us, see, acid that have one carbon atom less than that of the carbonyl compound. What is the product you are getting? You are getting an acid with less than, means the one carbon will be less in the product. Got it? That is called a oxidation of methyl ketone by haloform reaction. This reaction is important. Okay? Yes. Next one is reactions due to a hydrogen acidity of alpha hydrogens of aldehydes and ketones. What do you mean by alpha hydrogen? Suppose if you are taking a functional group in a compound, the hydrogen atom connected to the next carbon atom. Okay, see here I am writing CH3 CO CH3. So alpha means this carbon is called alpha carbon, and the hydrogen connected to this carbon is called alpha. This is also alpha. Understood? The carbon near to that of the functional group is called alpha carbon, and the hydrogen connected to that carbon is called alpha. So here we have 3 alpha hydrogen, here we have 3 alpha hydrogen. Got it? Yes. So don't be confused about the term. Okay. Then acidic nature of alpha hydrogen, aldehydes and ketones undergo number of reaction. Acidity of alpha hydrogen atoms in carbonyl compounds is due to the strong electron withdrawing effect of carbonyl group and resonance stabilization of the conjugate base. See here, this is the CO group. This CO group is, I told you, it is a electron withdrawing group. Carbonyl group is electron withdrawing group. So what will happen? This carbonyl group is electron withdrawing group means they will take all the electron density. I will write here separately. Okay, otherwise it will be confusing. I will write here. See, C double bond O. Some other groups are there. R group is there, and this is the carbon. This is alpha carbon. I am considering only this carbon, alpha carbon. This side also alpha carbons are there. Leave it. Okay, here this carbon is alpha carbon. Some other bonds are there. So CO bond is electron withdrawing group, I told you. CO bond is electron withdrawing group. Means they will take the electron density, right? So electrons are moving towards the CO group. Okay, so this here also the electrons are moving towards the CO group. It will be like this. Means the CO group is taking all the electron density from the neighboring carbon atom, from the alpha carbon atom. So this hydrogen can be easily removed as H plus ion. What is H plus? They are, I told you, H plus means they are not taking this electron. They are removing as H plus ion by leaving that pair of electrons. So electron donors are acids. Okay, so acidity of alpha hydrogen in carbonyl compounds is due to strong electron withdrawing effect also. When this carbonyl group is withdrawing the electron density on this carbon atom, it is easy to remove this alpha hydrogen as H plus ions. That's why they are acidic in nature. Got it? See, CO, here the hydrogen is retaken by the base. Base means this one is hydrogen is removing. So this one we have is as acid. Then you will get the corresponding species. Okay? Yes. Then the species formed is also resonance stabilized. Why? Because this double bond can move here, because this carbon, this hydrogen is removing as H plus. So the electrons will be moving to this carbon. See, this carbon will contain these 2 electrons. So what will happen? That electron can move to here. This minus charge indicate the electron. They can move here. Then automatically, in order to maintain the 4 bonds, this oxygen double bond will move here. Then this is not stable. What will happen? That will come back here. Then this will move here. That is this structure. That is called a resonance. We know what is resonance, right? Yes. Next one, aldol condensation. Again important. Aldol condensation. Okay. Aldehydes and ketones having at least 1 alpha hydrogen undergo a reaction in presence of dilute alkali as a catalyst to form beta hydroxy aldehydes or aldol. What is aldol? Aldol means in the name itself, aldehyde is there. Aldol. Aldol means alcohol is also there, right? So the compounds containing both aldehyde group and hydroxyl groups are called aldols. Aldol. Okay. See, I'm taking ethanol. Okay. This ethanol is producing aldol on reaction with the dilute base, sodium hydroxide. See, this OH group is there. CHO group is also there. Got it? Next, what will happen? This water, this OH and CHO group is there. So on heating, they will remove water molecule. Water molecule means nothing is happening in CHO group. This OH group from this carbon and hydrogen from the next carbon, means these two carbon. From the aldol, OH group from one carbon, whatever the carbon it may be, like that one. That carbon, the OH group, and from the next carbon, hydrogen will be removed as water. So when the dehydration is taking place, double bond will form. So a double bond will form between that carbon. This is called a aldol. Condensation means removing water. Aldol condensation. From the aldol, we are removing water. Okay. So here, if it is propanone, it is ketone, same reaction will happen. See, this is, see, aldehyde and alcohol is called aldol. Ketone containing alcohol means alkoxy means hydroxyl group is called a ketone. Ketone means keto group is there, CO group is there, OH group is also there. Same thing. When you are removing water, OH will go from here, hydrogen from here. So CH3C double bond will form there. That is called a aldol condensation or ketone condensation, like that. Got it? Yes. Next one, cross aldol condensation. In the previous one, we took two molecules of same molecules, right? See here, we have to take two same molecules, two ethanol molecules I am taking. In ketone, we are taking two propanone molecules, same molecules. See here, what is happening in the product? See, the two same, in the product you can see one ethanol contains two carbon. In the total product, 1, 2, 3, 4, because I am taking two ethanol molecule. Suppose if you are taking propanone, 1, 2, 3 in one reactant, so it will be 6. 1, 2, 3, 4, 5, 6 in the product. But crossed aldol condensation means I am taking two different aldehydes. Or I will take two different, don't take one aldehyde and one ketone, not like that. If you are taking aldehyde, take two different aldehydes. If you are taking ketone, take two different ketones. That is normal. If it is both the aldehydes are same or both the ketones are same, normal aldol condensation. If it is different, that is cross aldol condensation. Okay, same thing, but the product may contain, means the product may be two. Why? Because one CH3CH is combined with other one, means OH is coming at one position, means anyway they will combine. So this is the one possible product, this is the another possible product. If this product is removing water, you will get the first product 2-methyl butenol. If this one is undergoing dehydration, you will get this product. This is called a cross aldol products. So in the first one, you are getting only one product. If it is cross aldol condensation, you will get two products. Got it? Yes. So mechanism of aldol condensation is not there. Okay, only the product you have to study. Next one, Cannizzaro reaction. Again, the name reaction. Aldehydes which do not have an alpha hydrogen. So the aldol condensation is for the alpha hydrogen containing compound. I told you the carbonyl group is connected to carbon. That one containing alpha hydrogen. Cannizzaro reaction means do not have an alpha hydrogen, undergo self-oxidation and reduction. That is called if the oxidation and reduction is happening for the same species, that is called disproportionation. Same species is undergoing oxidation and reduction, that is called a disproportionation reaction. One aldehyde molecule is reduced to alcohol, another is oxidized to salt of the carboxylic acid. That is called a Cannizzaro reaction. Okay, see, memorize the reaction. No need to study the mechanism. Okay, then electrophilic substitution. Electrophilic substitution means same thing. Yes, electrophilic group is coming to the aldehyde or ketone. See here, NO2 group is coming. Understood? So the ring of the aromatic ring or aldehydes or ketone where the carbonic group functions as a meta-directing group. What is meta-directing group? I told you what is ortho, para and meta positions. If CHO group is there, the electrophile will move to the meta position. Meta position means the second position. Third position. Second position is ortho, third position is meta, fourth one is para. So the nitro group is means CHO group is there. The incoming electrophile will move to the meta position, the third position. Okay.